Hello there. Good morning, good afternoon, good evening, whatever time of day it is for you. Welcome back to the stream. This should be number 4. Yeah, it says it right there in the title. We're gonna work on our platformer game in MonoGame again. When we left off last time, we were working on implementing tile maps, and we stopped. Basically, when we stopped, we were working on the import logic. We were extending the content pipeline that MonoGame provides with our own logic to basically be able to import the tiled map editor specific file format. And that's what we're going to finish today, hopefully, if everything goes according to plan. And then we will be working with those tile maps. So we'll have to basically work on our general game framework a little bit. Mean Mr. Mustard says hello. Yeah, hi there, and welcome to the stream. Glad you could join us. Just as usual, please let me know if the setup is okay. Well, let me just, hold on. Let me get rid of this. So if the music is too loud or anything like that, just tell me. Or if the music is generally annoying or obnoxious, just let me know. If my voice is too quiet or something, if you can't hear me right, then yeah. Just let me know in the chat. And I guess we'll get started right away. I don't want to waste too much time here. We need to get this done. Because I really want to, get this done here, and but I don't want to do it off stream. We started this as a stream project, and that's what it's gonna be. So, and I figured, let me just maybe decrease the volume just a little bit. There. When we left off, we weren't quite finished. I was gonna continue watching the first stream, but this came on, so I wanted to watch it live. Okay, cool. Yeah, I mean, you can always catch up watching the old streams. So, no worries. Glad you're here. So let's see. I figured we have to refactor this just a little bit, because what I wasn't aware of is that MonoGame provides a base class for content items. So basically for everything that you want to be able to import. In previous projects, when I extended the content pipeline, which I did a lot, I never really used that base class because I didn't need it, because there was never really an external reference within a specific content file. But in our case, we do have that. We have like a dependency chain here. Whenever we import a tile set, we also need to import. No, sorry. When we import a tile map, we need to also import the referenced tile set. And when we import a tile set, we also need to import the referenced image or texture. Actually, to be honest, you didn't miss that much. We started extending, or actually we started creating an extension for the content pipeline tool so that we can process tiled maps. So maps that were created in this tile map editor named tiled. And so we were basically just handling the deserialization and stuff. So not much. We were extending just a little bit the general game framework, but only slightly. So you didn't miss that much. So let's see. What we're going to need is a subclass. Wait, this is tile maps. I want tile sets. Tile sets first. We're going to do the tile sets first because they're much simpler. So we're gonna need a class that that derives from content item, I think. Yeah, there it is. But there should also be a generic one. This is the non-generic one. Let's go to tile set data. There should be a generic one. Let me just look it up here. Actually, we could make it easier. I'm just thinking here, I think we could circumvent all of these external references and then just possibly just load them at runtime. Sorry for the short delay here, but I'm actually thinking if we could simplify this a little. No worries, Mr. Mean Mustard. Well, mean Mr. Mustard. No worries. If you're having trouble with the internet connection, that's fine. I mean, we all experience that from time to time. I'm just thinking here if we... So I guess in the importer we don't need to do more than just deserialize the XML and return the data. That's fine. But in the processor, either here in the processor we will have to establish the external references so that the dependencies are also automatically imported, or we will have to just load it at runtime so that only basically it doesn't actually create a texture, it just sets a path to the texture as a property or something, and then at runtime we would call like a load texture method. That would be easier, so we don't have to worry about the external references and stuff. Yeah, let's do that for now, so that we don't have to worry about this. What I'm gonna do here is I'm going to go into the tile set data. No, actually I'm going to go into the tile set class. And here we have this texture property. So let's for now add another property. Texture path, and I will make that read-only. And then we'll have a constructor here where we pass the texture path. Path. And then we will simply have void a method load texture. And here we can pass the content manager to actually do that. If someone were to pass null, we're going to throw an exception. Then here we'll say texture. Texture equals content manager load texture 2D. And pass the texture path. Actually, I'm going to make that a Boolean, and it'll return if the texture was successfully loaded. So this way we don't have to worry about external references. It would be a little bit cleaner and nicer if we did it with external references, but this way it's just faster, I guess. Mean Mr. Mustard is asking, how long have you been working with MonoGame? Can't really tell. I've been using it in the past for a couple projects, just in my spare time, from now and then. Last project is a couple months ago, that I did work on for a couple weeks, I guess. So hard to say collectively how long I've been using it. So this is fine. Now let's see. Go into the importer. Processor. And then here we'll just pass input.source. Image source. There. Now what we also need is a writer class. And let me see here. Tile sets. Oh, why didn't I put them here in the tile set? Well, never mind. So what the writer is responsible for is to basically serialize the tileset data into binary format that we can load it up at runtime. And there should be a generic version. Yeah, there should be one. The type is tileset. It's content typewriter, I think. Yeah. And now we have to implement this abstract class. There we go. Let me switch back to my dashboard here. I think there's another method that we can override, a virtual method. Get runtime type. Gets the assembly qualified name of the runtime target type. The runtime target type often matches the design time type, but may differ. But it doesn't differ in our case. So we don't need to override this virtual method. Because the tile set here will actually be the type that we write to a binary file, and also when we read it, it will be the same type. Here we can simply return tileset. Type of tileset dot full name. Hey. Full name. But not its assembly, but we do need the assembly as well. We need to concatenate it like this. I think this should be fine. Now, when writing the data to a file and reading it, we need to be careful with the order. We need to write the data in this exact same order that we read it. So, let's see. I don't think there's much to write actually. Yeah, it's fairly simple. So let's start with the name and just go property by property. So It's called output. Write. And then we can just write whatever. There's multiple overloads for all different types. And what we want to write here is the name. Then just duplicate the line and just... I should probably open this up in a separate window. Oh, that's not gonna work. Let's attach it somewhere maybe. Or simply... Yeah, this will be fine. So now I can always see the properties here. So we're not going to write the texture because we don't have it, we only have the path. Like I said, I would have liked to actually use external references so it would automatically resolve those references and actually create a texture instance instead of just a path string. But I want to make some progress here and I don't want to bother myself with these external references for too long. We can optimize it later on. Row count, we don't need that because it's a calculated value. We can just simply divide the tile count by column count. And I think that's it. Fairly simple for the tile set. So I guess we can close this here. Should be fine. And in order for us to test this, let's create a reader. I already created this content readers folder here, /namespace. Tile set reader. And it will have to inherit from content type reader. And here we specify the type, which is tileset. And we implement this abstract class. Oh, hi there, Pizzlify. Welcome to the stream. Glad to have you back. I think you've been in almost every stream so far, which is pretty cool. No, you're not really late. We're still working on this tileset import logic. And I think we're going to simplify the external reference stuff that we've been working on last time. And we're just going to resolve the references at runtime. So I've never actually had the case where this existing instance is not null. I don't know what this is used for actually. But I guess it's for optimizing loading the content. I think it's for when the content is actually cached. If you load it multiple times, it will not read the file again. It will just use an existing instance. I think that's what it's for. So if, let's say, if the existing instance is not null, we'll simply return the existing instance. But otherwise, we'll have to read from the file. So let's start with a name. So we can say read string. Yeah, and as you see, we don't have to specify anything here. Like, we can't tell it read this particular string, read this particular in this particular line or something. So that's why we have to go with the exact same order as we did when we wrote the file content. Oh, hello, Luca. It's for the second thread. Not sure what you mean. Enlighten me, please. This is a MonoGame application. So yeah, just a executable application. No WPF, no Windows Forms. And now I forgot the order again. Texture path, column count, tile count. So here we go. This should already do the job. Yes, Pistolfire, I will actually put that in a repository. I should have already done that. The only reason that I haven't done that so far is first of obviously being too lazy. No, but also I'm using a purchased asset bundle, and I cannot put those files in the public repository, obviously. So I will have to swap them out with some generic assets or something. So I have to git ignore them basically, and then I don't know. I'll have to just make sure that I don't accidentally put those files into the public repository. So that's it. And I think that's it actually, for the tile set at least. Now let's see. First of all, rebuild. So that the DLL for the pipeline tool, for the pipeline extension gets rebuilt. We have to create importer. Oh yeah, that's from the pipeline tool. We can ignore that for now. Oh yeah, this one here I can ignore. Let's delete it actually. I always jokingly refer to C# as Java++. Or if you look at it, if you're more of a glass half empty kind of guy, you could always also say Java is C#. But I'm just joking, obviously. I have nothing against Java, actually, I use it a lot. Not as much as C#, obviously, but yeah. Let's see. Content pipeline, let's open the tool. Where is it? Here. And we got this test tile set here. Let's rebuild it. Oh, I think I accidentally... Yeah, whoops. Okay, there's an error. Failed to create importer tileset importer. Let's see why. Oh yeah, the importer is missing for some reason. Why? I guess let's actually... Let's add the reference back in. What are we using? 6.1? 4.6.1. Pretty sure. Hold on. Oops. Yeah. Yeah, SFML is just a little more low level than MonoGame. In SFML, basically you focus on sprites, sound files, music. Just it's an abstraction basically of all of those kind of resources, but it doesn't have like it doesn't have pre-made classes for like other types that you would expect in a game framework. It's just a little more low level than MonoGame. But not that much more. So SFML is already pretty high level too. Ah, now it worked. So for some reason I had to recreate the DLL here manually. Okay, doesn't matter. So let's test this. So here, let's go and say, if we now call the load texture method, it's not going to work because we haven't actually imported the texture. But I'm just going to, for testing purposes, do it anyway. Hey. Oops. It's funny. Ah. Okay, for some reason it's not properly initialized, but why? remove this private default constructor. Let me check it in one of my previous projects here on GitHub. Okay. Let's here instead say assembly qualified name, and then let's actually do override the get runtime type, return tile set. Oh, yeah, whoops. See? Why would I return here the type of the tile set? That doesn't make sense. Oopsie. Obviously I need to return the type of the reader. So there. But now, since we changed the logic here in the content pipeline extension, we need to rebuild it, and hopefully the content pipeline will directly pick it up. Oh, hi Nightbird. No parameterless constructor. Why does it need one? Oh yeah. Now let's add it back in. But make it private. Why is it? How come it's all not initialized? Does it actually use the reader properly? No, it doesn't. Oh, maybe it does pass an existing instance for some reason. Let's put it here. But then it would return null. Why is this not working? That should be fine. Importer and processor are here. Maybe for some reason, let me rebuild it. We go back into the content pipeline tool, then that's fine. How come? Funny thing is, the name is actually set. Oh, I think I know why. Yeah. Okay. The reason is that these don't have setters. That's why it needs a default constructor as well. When it deserializes the binary, it needs to create an instance here, and that's why it needs a parameterless default constructor. It can be private, but then it's going to just simply call one by one the setters of the properties, and if there's no setter, then it's not going to work. They can be private as well. That's fine, but they have to exist. So now it should be working. How am I? Yeah, well, today I'm actually quite okay, I guess. Yesterday I had a little bit of a downer, I guess. Yesterday I wasn't feeling too well. Don't know why exactly. That's why I also didn't. It's also why I didn't do a stream yesterday. Content creator could not be found. What are you talking about? Yeah, so now it's working. Yeah. So obviously the texture is null, and here it has the full path to the texture. I mean, I guess technically we could just use load the texture directly from the file system, but I don't think that's a good idea. So since it's now an absolute path, that doesn't make sense. It should be in a relative path relative to the content root directory. So let's go into the processor here. Luca, I prefer WPF because I prefer a proper view model over event-driven design. Event-driven design is quick and easy, yes, at first, but if the application grows, it just becomes a maintenance hell. So if you have a code behind with like, I don't know, 10, 12, 15, or even more event handler methods, it just gets messy over time. So I'd rather use a view model and a command pattern, but it also depends on the project. If it's just a really simple project, then forms will do. But anyway, yeah, we now have the texture path as an absolute path, and that doesn't really make too much sense. So, so here we pass the source. Instead, let's go. Get file name, and then we get just the file name. with the extension. Now you should try WPF. The general idea there is that instead of that you have a data binding mechanism between the view and the model. And if you get the hang of it, if you really learn how to do that, it's pretty powerful and pretty cool. And the only, yeah, people say Forms is dying, and actually I think it should be dying, but obviously it's not dying because a lot of people are just used to using it and just keep using it for that reason. But let's get some work done here. I guess we can just pass that. No, hold on. What I'm gonna do is say, I'm going to put a constant up here. Texture root path. Textures. Oh, I can't type today. So now if we put a... Yeah, we already have a folder textures here in our content folder. And let's actually say textures tile sets. And then we'll put a tile sets folder here. So obviously this is a very static way to do it, but for our purposes it'll be fine. ASP is far from dead. Maybe they mean it's dead in terms of that everybody should now be using ASP.NET Core instead. Yeah, it's not dead. I mean, people may prefer web application frameworks based on a different technology other than .NET. But I wouldn't say ASP.NET is dead. It's actually alive and thriving. But personally, I also tend to use ASP.NET Core over ASP.NET because it's the future. But anyway. So now it should give us the actual path relative to the content folder, and with that we can actually work. Let me just make sure that this works. Let's explicitly go here and say rebuild. Now yeah, I gotta say, I'm a little bit of a Microsoft fanboy when it comes to software development. Dumb Gamer asks, hey, sorry to interrupt, can you recommend some places for getting started with MonoGame? I have used Unity and GameMaker for a little while before, and I'm primarily a programmer. I can see where you're coming from if you're primarily a programmer, because yeah, for the programmatic approach, I guess MonoGame would be a little more suitable than Unity, I guess. But anyway, it's a matter of preference. But I don't know. How did I start? I guess I just trial and error. Never really used any tutorials or something. I just looked up the documentation. You can also reference the XNA documentation because it's 95% the same. But anyway. Oh, no, I don't need it twice. Did I already rebuild this? Well, let's do it anyway. And start it up again, and hopefully now... Like I said, I've never watched any tutorial series on MonoGame. I've never followed... yeah, that doesn't exist, and that's okay. I just wanted to check if the path is now relative. It should be. Yes. But funnily enough... Here it uses the Windows style directory separation, and here it doesn't. So to keep it consistent, we can just go. Oops. Because I think the content reader actually expects this one instead of the backslash. Pretty sure. I need to rebuild. So now it should be correct. S tile set. Yes, there we go. So that's perfect. That's exactly the way we want it. And now we need to actually import this tile set so that it works. Where is it? Here. This is the tile set that was used. Going to copy it first here. Then use the content pipeline. Luca, I don't know. I don't know how many parts this will take. This is basically just a fun project, so I don't... It's not planned out in any way. It's just... Let's work on this and let's see how it goes. That's it. So now the load texture method should work as well. No, it doesn't. Not found. Oh, there it is. Oh, right. Right. We need to exclude the format, the tiles, the extension. I guess we can just... There should be also... Yeah, get file name without extension. Mean Mr. Mustard says you got a new subscriber. Yeah, thank you very much. Thanks. And I'm sorry that sometimes these streams seem a little... Yeah, that we don't make too much progress, but this is just really, everything is really spontaneous. I didn't plan it out too much. I did actually plan the framework for loading the different game stages and stuff beforehand last time. So we're going to use this basically as a roadmap to implement that. But other than that, it's just supposed to be a fun dev session. Why is there still the... Did I rebuild it? Should not have the extension in it. It just said something about X and B, and that's not correct. No, it's not. Textures, tile sets. That's okay. Content, textures, tile sets. Or does it actually need to be a backslash? I don't think so. Hold on. No, it doesn't, as you can see here. Ah, okay, because... Okay, got it. You know what? Let's change this. Where's the tile set file? Here. We'll just trim off any slash characters, and that's it. I don't know who here is German and who's not. I don't know. I have no idea where my viewership is located. Most of them, I have no idea. So now it's working finally. The texture is properly loaded. That's fine. That's exactly what we want. Now we need to actually handle the tile maps. And the processor... Let's add it here. This public. What namespace is it in? There. Come on. So for the import part, it's fairly simple. Create a new file stream. And then we can deserialize that because it's just XML. Ah, it's in a different namespace. Let me just... So let's create an XML serializer first. The type will be tile map data. And then we can go XML serializer, deserialize, whoops. Pass the file stream here. And we need to obviously cast that because deserialize returns an object. And there we go. Now we need a processor. Oh, I forgot here. Time map importer. I really want to get this over with because I want to actually work on the game and not on these pipeline extensions, but we need them. What was the format again? TMX. Different namespace, so using, there we go, and call this time map processor, make it public, and inherit from content processor for tile maps data. Oh yeah, and the output type will be tileset. Ah, time map, of course. Oh yeah, we don't have that yet, so we need to create it. And that's going to be interesting. So I have a rough sketch here of just the classes that we need. I didn't detail them at all. But basically a tile map consists of tile map layers. Each tile map layer is of a different type. Either it's a tile layer or an object layer. The tile map layer class will be abstract, and there will be two different implementations of this abstract class, the tile map tile layer and the object layer. And that's what we're going to need. So I guess we should start, let's for now put them all in one file and then move them over in separate files. So this is going to be abstract. And let's see. Let's go back into the pipeline. extension assembly here. And let's see what the data, the layer actually consists of. It has an ID, it has a name, width, height, that's fine. The data here will be comma separated values with the IDs of the tiles. Guess we can already do this. Now it needs a width and a height. Has a name and an ID. The ID is an integer, name is a string. Okay, so now we have to kind of think how we're going to represent the tiles, because everything we really need is the ID of the tile. So I don't know if we need a tile class, because it's probably, if we had one, it wouldn't really do much. So really all we need is basically a two-dimensional array. I'm probably not going to use an array, but instead a list of lists, basically. Like a tile matrix. But the tiles are really just an ID. But I guess it wouldn't hurt to encapsulate the tile in a class in case we do need to somehow extend it. And we need to actually have a default constructor as well here because of deserialization reasons later. So let's move it in a separate, into a separate file already. Yeah, so Yannick says, never use two-dimensional arrays. It's so frustrating to work with. But yes, if you do have to resize them. And usually I don't use statically sized collections unless there's a good reason. And there might be a good reason, because the size of the tile map layers will never change at runtime. So it might actually be more suitable to use a fixed size collection like an array here. Actually, what I think I'm gonna do is say... First of all, let's do create a tile class, even though it's probably going to, for now at least, only have a property for the ID. And then I'm going to create another class, tile map. Let's call it just tile matrix. Oops. And I think in this particular case, we can even use a rectangular array. Like... I'm thinking about the deserialization. I hope that's not going to make to cause any problems here. But I don't think so. Anyway. Oops. So we're just going to use a two-dimensional array for now, because it's not ever going to change in size, so that's fine. Nah, we don't need that. I guess we could even have the tile be a struct. So that way we wouldn't allocate too much memory on the heap. Because it's just an ID. I don't think we'll ever... Technically we could, here in tiled, we could give every tile a set of properties and stuff like that. But in our case, we're not going to need that. So if it's just an ID, it would make sense to make it a struct. If at a later point we decide to incorporate like custom properties for each tile and stuff, then it would no longer make sense for it to be a struct. So I think I'm going to keep it a class for now. Let's skip the error handling for now. Actually, we should check if X and Y are in bounds, but that's fine for now. I guess we can have here a method for that. Oops, why? Yeah, that's fine. Ah, I got an idea. Let's create in the tile map tile. Or do we need this? No, actually, I don't think we need this. Oh yeah. Greater or equal to... Yeah, thanks. Sorry, I missed that. I'm just going to set it null. And actually, this doesn't actually do that much more. Yeah, I think we don't need that much more. But I also want to implement... Hey. Or just There. So that we can also do something like this. And I guess it makes sense to also have a setter. There we go. Let's go into the tile map layer, and each tile map layer hold on. Do we actually need a width and height for the object layer? I don't think so. No. So we can skip that. So let's create another class here that inherits from tile map layer. And it's going to have a tile matrix. We don't know the size yet. Pass the pass the ID and the name to the base constructor, and then here create a new tile matrix and pass the width and height. Sorry, had to take a sip of my soda. Oh, it says height. Whoops. Yeah, thanks. Yeah, I'm not the best at typing today, I don't know. Hey. Ah, we don't have a width and height property. And there we go. Oh no, that's absolutely fine. If you spot any mistakes or anything, or if you have any suggestions or ideas, let me know, no problem. Absolutely fine. Oh no, not at all. You're not annoying, you're not bothering anything. It's absolutely fine. Actually, I appreciate it if you point out any errors, bugs, mistakes. Okay, that's fine for now. We need a method for parsing the CSV. I guess I'm gonna have a static method here. We call it parse CSV. We will pass an ID, we will pass the name, and we will pass sorry, the CSV content. Because in the original format here, the time matrix is actually just a huge CSV string. Nightbird says he's actually working while watching the stream, so he's only here with half an ear, and that's absolutely fine. That's absolutely fine. Actually, I'd like to do the same thing. Have a stream open, like on a separate monitor. Have it running while I'm busy with with something else, and that's absolutely fine. So we need to parse the CSV. So that's actually fairly simple. It's just comma separated values, and it's actually using a comma, not a semicolon. So we'll say first we'll split the CSV by its lines. So we'll say CSV split Hey, what's wrong? Yeah. Nope. There should be a string separator. Overload. We need to pass the options. Yeah, that's why. Oops. Split options. Yeah, remove empty entries. That's okay. And then we need to iterate over these lines. And then again split them by the comma. Oh. I don't know what it is today with me and the keyboard. I'm at war with the keyboard today, I don't know. Oh yeah, we need to pass this essay. There. So now we have the IDs, but as strings, and we need them as integers. But since we know that they will always be numeric, it's fine to just parse them into integers. And let me see. Okay. Oh no, that's the height. I guess we can even make it simpler. Yeah, let's go. Yeah, I could do this, but this would be... guess we can do it more... Yeah. Well, actually, I think it's easier if we go... Oh no, we can't do that. I don't want to iterate over the IDs again, because I want to do as little iterations as possible. I guess I can just use... Oops. Yeah, I don't have the width yet. So I need to actually split at least the first line to know the width. Whoops. No. Now let's just go. Tile, map, tile. Let's do it like this. Hey, list of lists. So with every line, we will add a new list of tiles. There. And then we can here say time matrix. Ah, we already declared variable. And I guess we can have another constructor here. Oh, why did I put an underscore here? Oh, I already have I. Oh, there. No, ID doesn't exist yet. Or does it? Oh yeah, there. Whoops. Let's just say X. That's fine. Yeah, that's fine. Let's not make this read-only. Well, I guess we can. And then we can just have a private constructor. That takes in the tile matrix. And there we go. This should do the trick. So first split all the lines by the carriage return. But then I guess we don't actually need the height and width. Right? We can derive them from the tile matrix. There we go. Oh. Got the comma. There we go. But we need to create the array first. Whoops. Oh no, that's correct actually. So the... Wait, this is the width and this is the height. This should be the other way around. So if we get the number of rows, it will give us the height, and if we get the maximum value of the number of tiles in each row, then we will get the width, yeah. It's a little performance heavy to use max and count here, but that's okay for now. Hello, Lioncat Dev Studio. Yes, I'm using tiled. I'm currently writing some logic for importing and processing the tiled maps. Oh yeah. Here you can see that there should be a tile map layer type, so we can distinguish between object layers and tile layers. No, I'm not using MonoGame Extended. I'm well aware that I could be using MonoGame Extended, but yeah, we don't. We basically create our own custom tailored solution here that keeps it to a minimal. I could be using MonoGame Extended, but we're writing our own pipeline extensions. And I'm going to make that abstract. Oops. Because I know that MonoGame Extended already has a pipeline extension for tiled and stuff like that, but I thought, why not create our own solution and have some fun with it, and also basically only implement the parts that we actually need and keep it to a minimum. So now we will have to implement this abstract property here. And for tile map, tile layer, layer type will simply always return tile. I think in our example file we have 2 tile layers. Yeah, I think one of them is completely empty. Okay, this should be good. What you're doing is a good practice. What exactly? What exactly are you referring to? So now in the processor we can use our tile map here. Implement the abstract class. And now we can get started here. We probably still need some more properties, methods in our tile map. Methods, here, there's nothing in here. Actually, I forgot about this. Let's see. Let's look into the tile map data. Oh yeah, obviously we need to specify the tile width and tile height. That's very important. Oh. Like I said, I'm at war with the keyboard today. I don't know why. The keyboard didn't do anything to me. I don't know why. This keeps happening today. No clue. Width and height can technically be derived from the largest layer. I guess you were gonna type proper, then it auto-corrected to paper. I don't know. It's a funny typo though. Ah, yeah, we need the tileset references. Okay, yeah. Okay. So, for the tilesets, I thought best thing to do here to create a class, call it tileset reference. So not actually the tileset, just a reference. Because here, in the tile format, in the file format of the tiled map, it always needs to store the first global identifier of the tile, the first tile in the tile set. But that's not actually really a property of the tile set. It's a property of a reference to the tile set, if you know what I mean. Then here I will have the tile set. Your cell phone's just a little crazy sometimes. Okay, yeah, I get that. And we will again most likely need a default constructor for the deserialization, so I'm just going to again create a private constructor that does nothing. There we go. I can just... Why do I keep doing that manually? I mean, I can just right-click, quick, add null check, boom. And I like to keep those null checks in because I want to keep it very... to basically guarantee data integrity and consistency. So if someone was to pass null, that doesn't really make sense. So I'm going to throw an exception then. And let's go into the tile map here. Okay. Oh. I guess I could technically just use a point struct here and say size, but let's keep it consistent. What are you doing? I feel like both IntelliSense and my keyboard fail me today. I don't know why. And then we can say... I guess we don't need that. Let's just make it void. And then say references, add new reference. go. We could add a remove method, but we won't need it for now. Probably never, so let's not waste time on that. And then we'll have a add layer method. And here we will simply need to pass the layer type. Now we can go if. We can technically use the switch statement, but it's just going to be two different types here, so that's fine. That's fine. So if someone was to pass an illegal tile map layer type, it's going to throw an argument exception. Layer type. Yeah, we don't have the object layer type yet, so... And for the... Oh, we need to pass an ID as well here. And for the width and height. They will always be all the same size, right? So I guess... Yeah, we'll just go... And actually... There. And now... we can just use these values from the properties. Because they will always all be the same size. We will never have the case where one layer has a different size than another layer. That doesn't make sense, really. Maybe in very specific scenarios, but not in our case. It's fine. And I think for now, well, let me just check something here. Layers, tile sets, object group. Let's ignore the object groups for now. They're very important and we're going to need them, but for now I'm going to ignore them. Yeah, I just basically want to test if it's working so far. If the deserialization just generally works. So let's write the processor and say tile map. We need the tile height, tile width, and we can get that from the input. Don't know what's wrong. Okay, so that's that. Just check something here. Yeah, that'll be fine. And now, what else? We need to add the tilemap references. And I forget. Yeah, that's a layers property. Okay. Oh yeah, layers are always okay. We have object groups and we have layers. The object groups are basically just object layers. So these layers will all be representations of a tilemap tile layer. So that's okay. So let's say tilemap tile layer. Oh no, actually, tilemap tilemap add layer. Layer type in this case will always be tile, and ID would be layer.id. But I guess we should start with the tile sets, right? Oh yeah, we should create an instance here, so let's go. Ah. Let's keep it short here. Oh right, we only have the ID in the source. But we can do the same thing here as we did in the tile set and just load the actual tile set at runtime, and here just pass yeah. What do we need here? think I got an idea. In the tileset reference class, there. And then you can have here the method load tileset, pass the content manager, say tileset equals content manager load tileset, and then the asset name, which would be the tileset path. Similar to what we did in the tileset for loading the texture. And then in our tilemap class, we're not going to pass a tileset. I mean, yeah, we can do that. We can have one overload that takes a tileset, but also have an overload let's just go on. Oh no, actually, I'm going to call this one add tileset reference. And then here, no, hold on. We don't need that. So add a property here that determines whether or not the tileset has been loaded. And now let's see. So here we can pass the tileset instance. We can simply... Yeah, but we don't have that yet, right? Yeah. So yeah, we do need. And then we can have a method here, resolve or load tilesets. Pass the content manager. And then go for each tileset ref in tileset references. Call the load tileset method. Aha. Load tileset. And pass the content manager. There. So that way at runtime we can simply resolve those missing references or those missing assets. That should be fine. Now let's go into processor. Right, so here we have the path, but we still need to do the same thing as we did here in the tileset processor. We need to, because the path will be, well, actually here the path is just, the path here is always, it's not absolute. It's always relative to where this file is located. But we want it to always be in the content folder here, and then there will be a subfolder named tile maps, tile sets. Yeah, and that's it. So let's add a constant here. Oops. And I guess I can just remove this, and then we can say, since this is relative, we will just get simply, oops, say string path, ts path equals path get file name without extension. TS ref there. Source. Then concatenate it with, actually no, the other way around. Say tile set path. There. So now it will always be relative to our content folder. And I can pass that here. Perfect. That should be fine. So, okay, we need the tile map writer class now. Is there anything I forgot? Let's put it here for now. Implement the abstract class, there we go. Runtime type and runtime reader, we need to specify that by overriding those methods. For the reader, we don't have that yet, so let's create one. There we go. Implement the abstract class. For now, that's okay. We just want to make sure that the class exists. Assembly, yeah, there. And same thing for the, oops, for the runtime type, which will always be the assembly qualified name of the tilemap type, and that's fine. And that's now we need to write the properties of the tilemap. We actually forgot one thing, I think. The properties. We need those custom properties here that we can specify here. We need them for a couple purposes. For when we add collision and when we add generally if we want to add objects from within tiled here, but let's not worry about that for now. Let's see. Hey, output. Huh. I can't type today. I'm so sorry for that. I don't know what it is. Now, we need to write all of the properties of the tile map to this. This is just a binary writer, actually. So this class just inherits from binary writer. We need to write all of the properties using that binary writer. So let's see, that's going to be a lot. Technically what we could do here is have a method write or write to binary writer. And then do it here, because here we have a better overview of what we need to write. We could do that, and then we could just call this. But nah. Let's just open it in a separate window, I guess. Tile map. Okay, let's start with the tile width. What's the argument called again here? Value. Why does the tile height have a public setter? Can't type. Okay, that's it for the primitive properties, but we also have the layers and the tile set references, which will be a little more tricky, but just a little. For each, let's start with the tile set references. Oh, yeah, we can't get them, but we need to. So let's have a property here of type IEnumerable, tile set reference. And I guess if we want to properly encapsulate that, we would here need to do something like new read-only collection of tile set reference and pass the references here. That's a little small, it's annoying. I guess we don't need this anymore. Now, I guess let's create a method here. We need the content writer. And then we call this method here oh, there. Fine. And same for the layers. Let's create a method. Tile, map, tile, layer. Let's just call it layer. Let me see, tile map, tile layer. Problem is that this will also have to be deserialized, so I'm not sure if we can actually make it read-only. Same thing for these here. Start with the ID and the name, and then we'll have to think about the tile matrix, because the width and height is just directly taken from the tile matrix. So it doesn't make sense to write them here. Let's expose, where is it? Tile map. Tile map, tile layer. Let's convert this to a property. Encapsulate field, and but still use field. Actually, it's just... Never mind. Let's remove this and say right click and use property. There. Okay, Mean Mr. Mustard is saying goodbye in German. It's actually pretty good German. How long have you been learning German? Well, anyway, you're going now. So yeah, thanks for hanging out. Thanks for watching the stream. Always glad to have you here, and hopefully I'll see you next time. Have a good day. What am I doing here? This can be an auto property. Okay. Processor. Now we need to get the tile matrix and write each tile to the binary writer. And I guess the simplest way would be to go into the tile matrix class. And the tile matrix is really just an enumeration of tiles. I'm learning German since last summer. That's quite some impressive progress you've made there in just 1 year. So good job. Keep up the good work. So we're going to implement here the IEnumerable interface. Get enumerator, we will simply use the enumerator of the tiles. Oh yeah, it's not gonna work. Because that's going to be an enumeration of Oh no, actually, it should be fine. Oops. Oh. Oops. I think this should be fine. So now we can directly iterate over the tiles. Here in the writer, let's say for each tile in layer tile matrix. We're going to try to write the ID, but if there is no tile for some reason, then we're just going to write 0. I think that's it. So this should be fine. But we forgot one thing in the processor. Let's actually move this to a different class here. There. We forgot to actually parse the CSV. For that reason, I'm going to add another method here. Now let's just make it an overload of add layer. So you can directly pass a tile layer. Or, wait, let me see. I'm thinking of actually moving the parse method to the tile matrix, because what we're actually parsing is not the layer, it's the matrix. So that way, let's refactor this here. Let's put tile layer. Copy this, put it into the tile matrix. And have it return a tile matrix. Oh. Then we don't need the name and stuff. There. I think that's much better, because now we can... The tile layer. Yeah, and the tile layer... Let's make this constructor public. So we can directly pass the tile matrix. So when we read it out again, we should be able to... Yeah, hold on. Let's go into the processor. Yeah, I think we do need a separate overload here. Where we just directly pass the tile map tile layer. Well, I guess we can just... There. Add a null check just to be sure. Then we'll say tile map. No, first we'll create a tile matrix. By calling the parseCSV method and pass the data. Oh, layer.data. There. So give us the tile matrix, and then we can create a layer like this. Perfect. There we go. Now what else? Let's go back into the writer. We write each tile, and that's fine. Now we need to call this method here. Oh, tile map layer. And we don't have a property or something to get the layers. Now we do. Oh yeah, we need to only get the ones of type tile map tile layer, because the object layers will be handled differently. Oops. There we go. So first we write the tile width and height, tile height, width and height, then all of the references, and then all of the layers. And now we need to read it back in the exact same order. Oh yeah, we already created the reader. So where is it? Writer. So first is tile width. We never wrote the ID, did we? Is there even an ID? No, it doesn't have an ID. Why would it need an ID? So 4 integers. I guess we can just loop. But we will have a problem with the layers and the tile set references because we don't know how many there are. So we need to have basically a temporary property for storing that. That's not gonna help, is it? Yes, it is. It is gonna help. Okay, we basically need. Okay, yeah. Let me tile set, tile map here. So that's fine. We can read that directly, but we don't know how many layers we have. The reader doesn't know that. But the writer, okay, yeah. We could basically store some metadata in the writer. We're perfectly free to write anything here into the binary writer that we want. So let's. So the first thing that we're going to do is say. Write the number of layers and write the number of tile set references. And if we call count, we will have, it'll force it to iterate over it. I guess it would make more sense to expose an integer property called layer count. We'll simply return the count property of the layers list. Same thing for tile set reference count. There. I guess we can put that right before we read the layers. And the other one we'll put right before the we write the references. And I think for readability's sake, I'm actually not going to use a loop here, even though it would kind of make sense, but I think it's better to go this way. So that we know exactly what it's reading. Yeah, we would store... I'm stupid. We need to store them in variables anyway, so... Yeah, that was kind of stupid. But hey, it's Sunday evening. My brain just wants some rest, I guess. At least here it's in the evening times. So I guess we don't need those anymore. I don't know what I was thinking. But anyway. So width, height, then tile set reference count. Reader, where's the reader? And now each tile set reference. So let's add a private method here. Read tile set reference. I guess we don't need that. There. We need the reader. Yeah. And then here we can just say so read back the number of tileset references there are, then loop over them. Tileset ref count. Now let's take another look at the writer. So we write the global ID and the path, that's all. Global ID, path. Global ID. And the path. And I guess we can just yield return. Or should we? Because that would mean that will only be executed if we actually do iterate over the enumerable. Nah, that's not a good idea. There we go, and then return them. Now the same thing for the layers. Get the layer count. And iterate over them. There we go. And then now we have to check again how we structured this. So first ID and then name. Got it. And now the tile matrix, which is like a whole nother process. So it's basically just a bunch of IDs. And again, we need to write some metadata into the binary, so we know that, so we know how many tiles there are. So we can't just write all of the IDs, because in the reader we wouldn't know how many tiles there are, so how many tiles to read. So let's say output, write the width of the layer. Oh, whoops. What did I do here? So after the ID and the name, we will read the width and the height. Okay, so let's go back into the reader. And then here we will have to pass that. And basically all we need to do us this. Get all of the IDs. Tile, map, tile. And then we can go tiles, add new tile, and say input, read int 32, which will give us the ID. And that's it. So now we have all the tiles. Oh, but I guess we can just start with layer width here, layer height. Now we need to set the tiles. I guess we can be a little smarter about this and just say let's create the tile matrix first. We don't need this separate list. So Yannick Bock is asking, what's the playlist that's perfect for programming? It's actually not a playlist. It's an app called Pretzel, and that app is for providing stream safe music, basically. So music where you don't have to worry about getting a copyright claim or something. It's basically publicly available music. Check it out, Pretzel. Just Google Pretzel app. And in the Pretzel app, I'm using the chiptune playlist. So I guess, yeah, there is a playlist. It's called chiptune. Get the ID, and now we will say matrix set tile. We can get X by dividing I. No, doing a modulo on I. Right. And the Y position would be I divided by layer height, correct? No, divided by layer width. So let's say, let's go here for an example. Let's say I is 1, 2, 3, 4, 5, 6, 7, 8. Let's say I is 8. If we divide that by the width, 8 divided by 5, we would get 1 as an integer division, which is correct. And if we do a modulo, 5 divided by 8 would be, modulo would be 3. Oh, but this is a 0, 1, 2, 3, 4, 5, 6, 7 actually. Yeah, obviously. Yeah, that's correct. That's correct. And now we can set the tile here. using the tile ID. Oops. And then we can return the matrix. And I guess we can optimize this by not repeatedly creating instances of the same tile. Because in this example, for example, we have the same tile, which 0. 0 basically means no tile at all. I guess we could use null for that. Which I guess would make sense. But here also we have 13, 13, 13, 13, and this will be the case in a lot of times. So I guess we could reuse the tiles actually. So let's cache them. Let's create a field here, or actually we don't need a field, we can put it here as a local variable. Say list of tiles. A tile map tile, I always forget. And call it tile cache. And then here we can say tile cache, let's say tile equals tile cache first or default, and get the first one with the matching ID. Oops. And if there is none, then we will create a new one. And we will also have to add it to the cache, so let's do it like this first. If tile equals null, tile, new tile, tile ID, and add it to the cache. Oops. So this way we can just reuse the same tile over and over without creating thousands and thousands of instances that will just clutter the memory. And there was another thing I wanted to do and I forget. Oh yeah, if the ID is 0, it basically just means there is no tile. So I guess we could just pass null. Or we could have an instance of tile. Okay, no, let's not do that. Let's create a tile instance with ID 0, and then in the tile set tile here, in the tile map tile, we will have a property is empty, and it will return if ID is less than or equal to 0. Okay, and I think we're done. Finally, tile map reader. So obviously we need to create the layer here. And those are actually just the tile layers, not the... Oh. Good point. We need to change something in the writer. Hold on. Tile map, tile layer. And there we go, and then return them. And then here we can create an instance of tile map, pass the tile height, the tile width, the width and the height, and then go for each layer in layers. Map, add layer, layer. And also the same thing for the references. I guess we can have a method for that as well. Oh. There we go. And that should be fine. And now we need to return this map. And just one thing. Here in the writer. When we write the tile layers, here we write the layer count, but the layer count would also include the object layers. But that's not what we want here. We want only the tile layers. So instead I'm going to say layers where or count type, layer type equals tile. So count the number of layers where the layer type is tile. That's what I want to write here. Yep. And that should be it. Now we first need to import the tile sets, both of them. Well, I guess technically we don't need to. Not at this point. Oops. Let's create a excuse me, a tile map folder here. Test tiled map, copy it right into that folder, open the content pipeline. There it is. And it's already picked up the tile map importer and processor. That's perfect. Now let's see. I probably forgot something, but let's see. Oh, it worked. Okay, that's good. But let's see if it actually loads it properly as well. Let's just test that by going into our MonoGame class here. Let's say tile map, test map equals content, load, tile map. And now I forget the name. It was something like test, oh there it is. Test tiled map 1. And I probably forgot something, but we'll see. Yeah, for now we don't need to do anything about it here. Let's just say debug. Okay, content file was not found. Okay, let's see. What did we do wrong? Let's go here. Tile map importer. Importer is fine. It just deserializes the XML. Processor will then wait, what did it say exactly? File not found, could not find file. Apparently the extension is still in it for some reason. Test tiled map. Ah. Test. Oh! Nah, it was just me being stupid again here. There. Okay, so at least no exception. Now let's see. Test map. Height 100, that's good. Layer count 0, that's not good. So the layers were not properly deserialized. But we'll look into that. Tile height is okay too. Same with the references, also not deserialized properly. Yeah, the layers could not be deserialized, and I think that's because, let's see. Because it's trying to... Wait. Is it even using the reader? Let's try an experiment here. I want to see if the reader is even executed. Because it should throw an exception here. But it doesn't, it just uses the default serialization behavior. Why is that? Possibly because our pipeline tool needs a reference to the assembly that contains the reader. Or does it? It doesn't really make too much sense. Why doesn't it use the reader? Is it because... Okay, let me see. Is it because I'm overriding this get runtime type? So I could imagine that if you override this, it'll completely ignore the runtime reader here, and it'll just use the runtime type and use default deserialization. So let's comment this out here. Because this is not mandatory to override. It's not abstract, it's virtual. So just make sure that there's a... Yeah. The reader should now be called at runtime. Why is it not called? It's not good. Gets the runtime reader gets the assembly qualified name of the runtime loader for this type. Yeah, that's what we're doing. But it doesn't seem to ever call this read method for some reason. Why? No, I thought there was maybe a separate overload where you could specify the reader, but no. I mean, that's what you do here in the writer. That's funny. I don't know why. This shouldn't be a problem. Oops. For some reason it doesn't use this reader. Now let's keep the debug breakpoints in there. Should be fine. Tile map reader, yeah, that's fine. The assembly qualified name of the runtime loader for this type. Yep, that's fine. It's funny. Wow. Should be called. Problem is we cannot really debug this here. Unless maybe... I guess there's a debug mode here. Let's try that. It'll ask me to open it here. No, it's not gonna get hit, or is it? Nope. Oh, I think... Oh, yeah, we need to decorate this with the content. Ah, content type. Writer attribute. Otherwise, this will not be used at all. Oh, whoops. But not for the reader, because that is specified here. So this should work now. Same thing goes for the tile set. I just simply forgot to decorate it with the attribute. Very interesting. Now, this should fix it. And therefore, we also no longer need those private default constructors, because we only needed them because it was using the default serialization logic, which is simply call the default constructor and then set all of the properties accordingly. And I think this way we don't need them anymore. So let's go back into the content pipeline, rebuild. Okay, the tile map could not be built. There is a null reference somewhere, but why? In the writer, probably, I guess. Writer. Oops. The layers, I guess it's either the references, the layers. It's fairly stupid that we cannot really debug this, since it's not directly executed. But what we can do is have a look. Importer is fine. Processor, let's see. I guess we could add a bunch of logs here. Let's take a look. Tile map. Okay, these are actually instantiated, that's fine. about the layers. Should be fine too. Guess we forgot something in the processor, but then why would it be null? Fine. Well, being able to debug this would be great, but I'm afraid that's not gonna work. Does actually work. Okay, great. We just need to use the debug mode in the content pipeline. Okay, perfect. That's good to know. So this works fine. Now we're in the writer. Let's take a look at the value. We have all of the layers there, that's fine. There are 2 layers, that's exactly right, that's perfect. The tile matrix is also instantiated, so that's fine. So I'm not sure where exactly the null reference exception is thrown. There's the layer. There. Oh, okay, I get it. Yeah, it's because of our implementation of the IEnumerable interface. We made some mistake there. And I was actually worried about that because, let's see. I guess the enumerator can't be cast. And that's a bit of a problem here with a rectangular array. But I guess we can go. And let's cast this to a one-dimensional array. Can I flatten this? I guess technically we could just say tiles. Oh no, select is not going to work with a two-dimensional array. That's why we shouldn't have used a multi-dimensional array here. We need to flatten this now. Oh, but I guess since it's an enumerator... Oh no, that's not gonna work. I mean, we can convert it to a one-dimensional array, that's no problem. But do we really want this overhead? I guess we don't really have a choice here. Oh, tile map tile. Huh. Why do I keep messing this up? So we just create a new array, and then we go oh. This is supposed to be a Y. Oh. right? This should work. Oh. Yeah, yeah. We actually did get us into some problems here, but it's not that big a deal. But the index is not correct. It should be oh, actually, is it? No, it should be y multiplied by x. Wait. First iteration, x will be 0. Actually, no. And so now here I can say that'll be y multiplied by the width plus x, correct? Should be right. I guess so. Oh, I didn't okay, sorry. Yeah, this didn't work because I didn't rebuild this assembly here. Let's just make sure. Rebuild it all. This is because of the content pipeline, that's fine. Still? Maybe it's using this method instead. Oh. Anyway. Ray Hancock, hello there. Welcome to the stream. Yes, of course, I'm planning to finish those tutorials as soon as possible. Sorry I haven't uploaded the new episode this weekend. But I will, as soon as possible, upload the next episode. It's just the editing that takes a little bit of time, and yeah. Sorry about that. I will upload it. I'll try to do that tomorrow. My plan was to do it yesterday, but again, didn't get to do it yesterday. Okay, this should be correct. Why is it null then? I guess a different approach would be to go... Why is this not... Turns the enumerator for the array, yeah, obviously. I guess if we simply... Let's just use a list. Then we don't even need the index. But we need to make sure that it's added in the right order. I guess we should start with Y, and then X, so that we go row-wise and not column-wise. And then we can just say tiles there. It's much simpler. You're the best. Thank you. Yeah, I hope I can keep that promise. I don't know how long I will be at work tomorrow, but I'll try, definitely. Pipeline. First of all, let's build this, and then the pipeline. Oh, why did I not see this? Obviously. Okay, it's working now. Seems okay. So let's test the actual game again. So now it's actually calling the reader. That's perfect. Yeah, existing instance is null. It should be. Fine. Two layers, that's perfect. Okay, now it's working. Finally. Took us way too long, but okay. Yeah. Tileset references are there, layers are there. Now we just need to make sure that we import the tileset first. So let's go. Up. Yeah. Best thing would be to open the content here again. Add existing folder, tile sets. Not use the debug mode. Oops. Build there. It's fine. And if I did it correctly... Oh, I also need to add the other. It's using 2 tile sets. It's also using this one here, with all of the objects in it. It's just called Objects Tile Set. It's easy to remember. Now I need to check. It's called ninjobby32.tsx. Well, let's actually, maybe let's create some test data. This was really just me just fiddling with the editor here to have something to work on. But let's actually create a very simple map here that we will be using as our test stage. Let's close all of this. No, we don't need to save it. So first things first, create the tile set. New tile set. Let's call it Ninja Ground. Source image will be this one. And the thing is that in the actual tile set, it says it here in the title, it's 64 by 64 pixels for each tile. But we're going to go with 32 by 32. And the reason for that is that in the other tile set that we're going to mix with this one, there are actually tiles that are just 32 by 32 pixels. Let me show you. Here, these ones, for example, they're just actually 32 by 32, so we can't just go with 64 by 64. So we use 32 by 32, that's fine. I'm going to create a new folder here. Ninja Game Assets. And there we go, and that's fine. We don't need to do anything more than that. Now let's create the other tile set. New tile set, call it Ninja Obbies. Or let's call it Objects. Ninja Objects. There we go. It's also 32 by 32. That's fine. So here, as you can see, these are actually 32 by 32. And now create a new tile map. Let's make it really small so that it's easy to test. So let's say 30 by 30. Tile size is 32 by 32. Ninja test map. Let's create a very, very simple map here. Now rename this layer. No, that's fine. Why can't I select multiple at once? Should be able to select multiple. Pretty sure it's possible. Oh yeah. For some reason I had random mode enabled. It's just going to be really simple. Maybe something like this. Yes, these are still the same tiles, Nightbird. We're just creating a very, very simple test map here. Let's create an object layer, and I'm going to name it collision layer. And that's for, well, the collisions. And I'm going to use these rectangles here to determine what areas should be checked for collisions. I guess we can use a polygon. There. And in order to tell our game that these objects are actually for collision, we're going to introduce a convention. The name doesn't really matter, but the type will be collider. So then in the logic we can check if the type is collider, we will have to handle it appropriately and create instances of our collider class. Also, I'm going to add an object here. First of all, let's create another tile layer. Let's call it background objects. Here I'm going to use these. Maybe I should move this a little. Can I move it? Can I remove it? I think I can't. Let's remove this actually. There, and I'm just going to add these background objects here. There's an in. Beautiful. Then maybe this thing here. Maybe like a tree or something. There. It's just for testing, so that's fine. Okay. Maybe down here, let's do this. I know, then I have to add collision. Doesn't matter. Okay, so that's fine. Let's use these actually. I'm gonna copy these two tile sets here. Ninja ground and ninja objects. And the tile map also. Perfect. So now we need to import the textures first, which we do here. We already have them. Add existing item. There. So we need to build these textures first. Then the tile sets, which I forgot to include. Build them. Okay. So now if we go into our Ninja Game class, we should be able to call the test map load tilesets method, pass the content. Then the tile set should also load its map, its image. There we go. And this should do the trick. Content file was not found. Ninja object 32. Oh, whoops. I'm using... Whoa. That was stupid. Here, I'm loading the wrong run. It should be Ninja map or something. Ninja test map. Okay, now it's working. And now the tile sets, the tile set references should include the actual tile set. Yes, they do. And the tile set should have the appropriate texture. Yes, they do. That's perfect. Okay, great. Now we can use this to actually render the map. Finally, I will take a 5 to 10 minute break. I'll be right back. And then we'll get to actually... I think we'll do the rendering first and then process the objects. For now, we actually want to see something and see the map in the game, so that's the most important part. So, took a little while to process this stuff, but, well, it's out of the way now, so that's great. So, I'll take a 5 or 10 minute break. Be right back. Okay, I'm back. Back from my break. So, now that this is out of the way, let's make sure that we can actually see the map in action. Okay. So now, if we take a look here at this quick diagram draft, we now have this entire, well, not the entire thing, we still need to work on some things there, but we have this tile map part of this UML diagram down. Hold on, let me remove this AFK text there. Excuse me. Now we need to model this part. Basically every stage will be considered a scene, just like every menu or everything else will be considered a scene. And we need to implement the scene and the scene manager, basically. So. I'm going to add a namespace here, scene management. First of all, let's create the scene definition class here, which is a very simple class, which will actually also be a custom content type, which we create an importer for. But this time around, it's going to be very, very simple. It's going to be a JSON file where we just specify those 4 properties here, and then the JSON will be deserialized, and that's it. For now, we don't have to worry about the import part. We're just going to, for testing purposes, create them programmatically without needing to import them. Oh, what happened here? Okay, so basically this is just a simple data structure that holds some data so that we can reference our different scenes. So the scene ID will be what identifies each scene, which will be like a stage or something. The name will be, well, just a name for maybe for displaying purposes. Then each scene definition can have a tile map path to point at basically the tile map that we want to use for this scene. If it's like a menu or something else that doesn't need a tile map, this will just simply be null or an empty string. And then we have this very interesting scene delegate class name, and that's basically my idea was each scene can have a scene delegate. And the scene delegate is responsible for handling the logic that is not tied or associated with a specific object in the scene, but more with the scene itself. So like initializing logic, like spawn the player, I don't know, spawn some enemy, I don't know. Just some let's say global stage logic. And for menus, this would basically be the menu logic. And this will be handled by the scene delegate object. So the scene will just delegate some of the logic to this scene delegate object. So yeah, so we can have, if we want our stage to have specific logic, we would specify the class name here of the scene delegate, and then we would instantiate that class and call the appropriate callback methods in that delegate object from within the scene class. And you will see what I mean as we progress here. So scene definition is fine. I guess I could override the toString method. Now, that's fine. That's really it for the scene definition. Now we need the scene. And it's not going to be abstract. It's not that we create a different subclass for each stage or something. That's what the delegates will be for. We need the entity manager so the scene can add and remove objects or entities. And the tile map, which can be null in case it is like a title menu, stage selection menu, stuff like that. Those don't need a tile map. What's going on? I guess I can go has tile map. There. What else? Oh yeah. Well, let's call this process tile map. Now we need this scene delegate interface. And it will have 3 methods: on initialize, on update, and on unload. I guess we could add an on draw method as well. don't think we'll need it. Move this to a different file. Now here we need to add the delegate. Let's add a constructor. The scene delegate might be null, so let's put it somewhere else. Put it here. I guess it's more likely for the tile map to be null. Let's go. So by default, tile map will be null. Here we say scene delegate on initialize. There we go. Oh no, here we don't need anything. I called it create entities here, but it makes more sense to call it process tile map, because this method is basically supposed to be responsible for going through the tile map, checking for all of the objects in the tile map, and then creating appropriate instances here, like colliders and stuff like that. Okay, that's it for now. Let's add the scene manager. And the scene manager will have a collection of all of the scene definitions. And we'll have a method. What did I call it? Load scene definitions. Here we can pass the content manager. And we will then use the content manager to load all of the different scene definitions and store them here in this list. For now, like I said, we will not actually implement an importer for the pipeline tool because I've had enough of that for today. But we'll just add them programmatically. So, but anyway, we can implement this here and say yeah, thank you for stopping by, Nightbird. Have a good evening and see you next time. Thank you so much. Always glad to have you here. Bye. I guess we'll have to loop through a folder here, through all of the files. Let's add a content folder here. Let's call it scene definitions. Let's give it a default value here. I guess I can just do this. There. And then I will iterate over this, over all of the files in this folder. Let's say, I guess we can get the root folder here. Yeah. So content root. There we go. This should give us the full path of the of this folder here, of this scene definitions folder. And that should be in the system.io namespace. In the directory, in the directory class, there should be enumerate files, I think. Yeah. With that, we can iterate over all of the different file names. So, and then we can say get file name without extension, file name, and then we can say content manager load scene definition. File without ext. Here we should say oops. The scene definition is not null, then the load was successful, and we can add it to the scene definitions. And we return the number of scenes that have been loaded. And I think this music's a little too aggressive. Let's change that. Yeah, that's okay. So get all of the files, that's fine. This should be okay. For now, we will add them programmatically. So I will add another method here, add scene definition. Add a null check. And if we already have a scene definition with the same ID, then we want to throw an exception. And then we'll say a scene definition with ID already exists. Otherwise, we'll just add it to our collection of scene definitions. And that's it. Now we'll have a load scene method where we just pass the ID. And in case the scene with the given ID is not found, we would just return false. I guess we could also throw an exception or something, but for now, returning false is okay. There we go. The scene manager will also need a reference to the entity manager. So that we can pass it to the scene. Actually, let's just return the scene that is created. And here return null if that doesn't work. Oops. Pass null for now. Basically, we need to create an instance of the scene delegate if there is one. So let's create a method here. Oh. If it's not given, if it's null or white space, Are you kidding me? In that case, we will just return null, because that means there is none. Otherwise, we will create an instance of the specified class. And for that, we can use an activator. The activator class has a public static method where you can just pass the name of a type and it'll return an instance. It'll use the default constructor, so we will always have to make sure that our implementation of the scene delegate provides a parameterless default constructor. We need to specify the type. We can pass the type name here. And this could fail. This could throw an exception, obviously. I mean, for example, if the class that... well, first of all, this type might not even exist. Someone might have passed, I don't know, Bob Ross here. And if there's no type named Bob Ross, this is not going to work. Or there might be an actual type of that name, but there's no parameterless default constructor. And then create instance won't work. So this might throw exceptions here. So we'll have to handle that. Oh. It's usually not that wise of an idea to go with this catch-all approach, but in our case, I guess it's okay. Now we'll actually create a class for that. Let's call scene delegate exception. It derives from the extension from the exception class. Oops. There. And now in our scene manager we can say throw new scene delegate exception. Message will be an could not create instance of the specified scene delegate. And then here we'll add actual name here. Then as a second parameter we'll pass the exception that was raised. So if we specify some weird value that doesn't represent an actual class name for the scene delegate name, then it will throw this exception and we'll know that this was what the problem was. Now we need to also load the tile set, the tile map, I mean, if there is one. So if it's not null or white space, we will actually say tile map come on. Oh, we need to pass the content manager. I guess the content manager may as well be a field. Yeah, that makes sense. So let's remove this here. Oh. There we go. Oops. Load tile map. Pass the name, which is scenedef tile map path trim. Trim just in case they are leading or treading white spaces. And then we'll call the load tilesets method and pass the content manager in. And that's it. And then we can pass, oh, need to do this because we need the tile map here to pass it to the constructor of the scene. Perfect. Now the scene will have to render the tile map. So I guess we do need a draw method. But we don't need a sprite batch because that is specified by the entity manager. The entity manager uses 12 different, or 10? Oh no, a couple of different sprite batches for rendering. But we may sometimes need the game time, so. Now, our entity manager can only render entities. We could think about changing that a little and give our tile map class a draw method or something. But I think what I'm going to do is I'm going to go into the entities namespace, create a folder here, tile maps, and I'm going to create a class tile map layer renderer which will be an implementation of the iGame entity interface. And it will be responsible for rendering a single tile map layer. So it'll need a constructor where we can pass in the tile map layer, and it's actually going to only use tile map tile layers because there's nothing to render for object layers. Create and initialize property. There. And now we can iterate over the tiles in the tile map layer and draw each of the tiles. But I think what I want to do is, because if we use the iterator of the tile matrix here, it'll always have the overhead of creating this list and stuff like that, which is not ideal. So what I'm gonna do is I'm going to add a method here to the tile matrix called for each tile, and I will pass in an action delegate. And then simply what it will do is we'll call this delegate for each of the tiles. But actually, let's not use an action delegate, let's use a func delegate that takes in 2 integers. Oh no, actually, action is fine. But it will need 2 integer parameters. And then we will invoke this action and pass in the x and the y coordinate of the tile. It should be fine, because now here we could, in the tile map layer renderer, we can say tile map layer tile layer tile matrix for each tile. Then here we can pass a function or an anonymous method. Let's say x, y. Then we can say sprite batch draw. The texture will be, oh, that depends. That depends on the ID of the tile. Yeah, that completely depends on the ID of the tile. because if we look it up here, each tile set here it's specified which is the first ID, and here if there is an ID that is higher than 51, it will be actually from this tile set, and otherwise it's from this tile set. So we need to determine that, which tile set it is, based on the ID. And I guess the tile map layer should, I guess, have a reference to the tile map that it belongs to. Let me think. Yeah. In the tile map layer, in the constructor, I will add a tile map. Let's say parent tile map. Let's add a field for that. And then in the tile map layer, oh, actually, do we need this? Hold on. Yeah. Let's not use a field because we need to access it from the outside. So let's say create and initialize property, and we have a read-only property somewhere here, there. And then in the tile map, we will add a method called get tile set by global ID, global tile ID. And I guess it should return the first tile set where the first ID is lower or equal to or less than equal to the given ID. So first or default, first GID less than or equal to GID, and then from that we'll take the tile set and return that. Right? That should be fine. And now in our renderer, we can say tile layer dot tiles parent tile map, get tile set by global tile ID, I guess we can hear, yeah, okay. First we'll get the tile equals tile map tile layer dot get tile tile matrix get tile, pass x and y. Then here we can pass the ID of the tile. Let's say if it's null, we'll pass 0. Tile set texture. Now we need the destination. Well, I guess just the position would be fine. I guess the position we can calculate by X and Y and multiplying them by the width and height of the tiles respectively. No, it's going to be a vector. Now we need the source rectangle from the texture. And we can get that from the tile set. Get tile bounds. But I guess here they are local. Hold on. Yeah, here it assumes that the tile ID is the local tile ID. Starting with 1. Hold on. Oh, I guess, yeah, for that we can just pass X and Y, that's okay. Get tile bounds X, Y. Color white, no tint color basically. And that should be fine. I hope. Hold on, I'll be right back. Just 2 minutes. Sorry. I have to take care of something. Just 2 minutes. I'll be right back. Alright, I'm back. So we'll just, basically, I want to get this to render now, and then we'll call it a day. So, as soon as we can actually see our map on the screen, then we'll be through for today. Yeah, so now obviously we need to refactor a little bit, because now if we want to start, it will not build. And that's because we changed the... We changed the... constructor of the tilemap layer. So we need to adjust that. Here we added the tilemap layer. Here we added the parent tilemap. We need to do that here as well. We're going to have a problem here, don't we? No, we just have to pass. This here. There we go. Here we can also just pass the tilemap. Perfect. Got it. So now we have the tilemap layer renderer. Let's give the tilemap a position property. Here we will add the position of the tilemap itself. There we go. That's fine. Now let's see. With that all of the way, let's go into the scene. Process tile map. So if there is no tile map, we'll do nothing. And otherwise, we'll iterate over the tiles, over the layers. And then for each of them, we'll create a renderer. Pass in the tile layer. Use the entity manager, whoops, to add it actually to the game. Then the draw method will simply call the draw method of the entity manager. I guess the scene manager should also keep track of the current scene. Like, it has should have a property that stores the current scene. And after loading here, if it was successful, well, can't be null. But in this case, oh no, that's fine. Okay. Okay, so now that this is taken care of, I will actually create an interface for this. Extract interface. That's fine. And now in our game class here, Ninja Game, there we go. I will add the scene manager as a service. Here. We need to create an instance. We don't have the entity manager yet, or do we? Yeah, I guess we can just create an instance here. Technically, I guess the entity manager could also be a game service. Not sure if the graphics device is actually initialized here already. We'll see. No, I think it's not before the load content method that the graphics device is actually initialized, so. Let's put this here. Oh. Okay, so let's just check if the graphics device is properly initialized and stuff. Okay. Yeah, looks good. Okay, so let's see. So I guess in the update method, first of all, I want to store this in a field. Then in the update method, I'm going to say scene manager update. Scene manager current scene update. And same thing for the draw method. That should do. Now in the load content method, let's for now programmatically create a scene definition. So just for testing purposes. Let's call it test scene def. Name will be test scene. The ID will also be test scene. There will not yet be a delegate, so that's fine, but there will be a tile map, so which is this one. And now we can say scene manager, load scene, test scene. This should do the trick. So then the scene is loaded. That means the current scene of the scene manager changes. Yeah, but we also need to call the initialize method of the scene that is created here, because otherwise the process time map method won't be called. So, but I guess that can be handled by the scene manager itself. So right after loading the scene, here we'll say current scene initialize. I probably forgot something, but let's see. Oh, we need to also rebuild our content because we changed the tile map layer constructor. Other way around. Let's open up the content pipeline again, and we only need to recreate the tile map here. It worked. And I think that's it. Let's see. Okay, there's nothing here, but we probably forgot to do something here along the way. We never load the tile map, do we? Oh yes, we do in the scene manager, I think. Scene manager. Load scene, yeah, here. Well, let's see if this actually works. Okay, the breakpoint is not triggered, so apparently this is null for some reason. Well, let's see. Yeah, scene diff is null. Why? We pass test scene. Did we never actually add the test? Oh yeah, I think we didn't. Yeah, we just created the instance, but we never did anything with it. We actually need to go here, say scene manager, add scene definition, test scene def. So now it should be found. Yeah. Tile map should be loaded correctly. Yes, let's see, tile map. Looks good. Layers are 2, that's perfect. It should have its textures as well. Yep, okay, that's good. Continue. But it's still not rendering. I forgot something along the way. Let's have a look at the scene. Process tile map. Let's put a breakpoint here. Okay, that's working. Okay, that's fine. This is fine, but also what I already saw here, something that we forgot is to actually assign the draw order and the render layer. So we cycle or iterate over the tile layers, and I guess the first one should be the first layer and so on. So let's say int let me just go into graphics, render layer. Okay. We'll start with 0. Well, I guess we can just say render layer 1. And then cast that to an integer. And then here I'll say render layer plus plus. Oops, render layer. Oops. and then we'll cast it back to an actual render layer. Draw order is okay, 0 will be okay for now, which will be the default, so we don't have to worry about that. So that's fine. Let's see if the draw method of the tile map layer renderer is actually called. It should be 2 now. Yep. No, it's not called. Why is it not called? Because we never... Hold on. Let's go into the MonoGame class here, draw. Scene manager, current scene, draw. That's fine. Entity manager, draw. Here we forgot to actually call the begin method, but that's not the problem. If this was the problem, then we would have an exception would have been thrown. But this doesn't make sense because now we do it for each entity. We need to do it for each group. So for each render layer, get the appropriate sprite batch, start a call, a draw call, get all the entities, draw them, and then end the draw call. That's fine. But it seems like the draw method is never called for some reason. Yes, it is. But entities is 0. Why is entities 0? Let's continue. Still 0. Still 0. Still 0. Okay, for some reason it's always 0. And I think I know why. Add entity. Yes, we never call the update method. Or do we? Yes, I think we do. Do we? Yeah, if we didn't... No, hold on. Let's take a look at the update method here. So for each entity, order them by update order, that's fine, then update. Then For each entity to add them to the entities. For each entity to remove them from the entities. That's fine. But I guess we never called this. So let's go to the scene. Yeah, here in the scene we need to... Or maybe not in the scene. Maybe this should be handled by the game, not by the scene. We should store it as a field. There we go. And also call update. So now it's actually called. Let's look at the tile. ID is 0, which I guess is correct, because the first one here is 0. Null reference. There's a null reference somewhere. Tile set was null for some reason. Why could that be? I guess when it's read back. No, that should be fine. It shouldn't be null. Why is the tile map now? Yeah, it's now. Why? Oh, because probably the get tile set, there's something wrong with this method, probably. What's... Okay, let's put a breakpoint here. Oh yeah, okay, yeah, obviously when the global identifier is 0, it doesn't refer to any tile set, because there is no tile to render. So that is actually correct. We just didn't think of it. So, tile map layer, renderer, where is it? So, if there is no tile set, that means we have nothing to render, so I guess we can just go... and skip this one. And the return is actually the return of this anonymous method here, not of the draw method. So this should be fine. Okay, it's really laggy. That's not good. Let's see, what could that be? Too many draw calls? Can't be. That can't be the reason. It's not that many tiles. Let's see. First of all, for testing purposes, I guess it should create two instances of the render layer. Layer renderer, so that's fine. Why is it all laggy? It's super laggy now. And obviously there's no tile map. If I don't add this, let's see if this reduces the lag. Probably it does. Yeah. So now it doesn't lag anymore. It's because of the draw method. There's something wrong with it. Let's switch up the music here. Don't really like having too much lyrics going on here in the background. It can't be that bad. Layer. I mean, it does it for each tile. Okay, how many tiles do we have here in our tile map? I guess it was 30 by 30, right? So 900. It's not that much. But there's two layers, so it's 1800. Let's break this up a little here, so we can debug it better. I mean, thing is, in a different project, I also have tile maps, which I handle differently. I did not use tiled for that. I just create them manually, basically. I create them programmatically. But it also has, like, I don't know, 50 by 50 tiles, and everything is perfectly smooth. So I don't know exactly what's going on, why the performance is suffering so much from this. There must be some problem here. It shouldn't suffer that much, the performance. Oops, need to add. Ah. I don't like that music. There shouldn't be any lyrics. Okay, the position is huge for some reason. $361? That can't be, right? I mean, it's 30 by 30. I mean, I guess it can be correct. So this is 30 pixels, 30, 60, 90, 180. $60, 90, 120, 150, 180, 210, 240. I mean, I guess it can be. Okay, but these boundaries are way off. So that's probably the problem, because it tries to grab a portion from the texture that is way out of bounds. So this may be the problem, but what's going on? Oh, okay. We passed the X and Y position within the tile map, but we need the X and Y position within the tile set here to get the bounce. So we mix those two up. So let's see. Let's debug it again. But yeah, I know what the problem is now. And those huge values are also the reason why it's lagging, I think. Because it's trying to grab a portion of the tile set, or of the texture that is, yeah, out of bounds. And that's probably the reason. So the position should be correct. It's a position in the world. I guess that should be correct. X is 361. Can that be 361? I mean, this would be... Here it would be ID, X would be 29. Here it would be 30. Here it would be 60, 90, 120, 150, 180, 210, 240, 270, 300, 3... Yeah, it's exactly right. This is the first one, and that's 361. That's correct. Okay. So that is not the problem, but the tile bounce, the method is just wrong from the logic. It's just wrong. To get the tile bounce, we have to get the tile ID. So we need to get the tile, which we did. The ID is the global ID, right? So we need to subtract the first global ID in the tile set. And for that, let's go to the tilemap class and have a method get local tile ID. Or even better. Here, let's actually return the reference. Tileset reference. Reference. Tileset reference. There we go. Remove this. Now, this will no longer compile, but that's fine. So if the reference or the tileset in the reference is null, we won't do anything. Otherwise, get the tileset. And in the tileset ref, tileset reference, we'll have a method get local tile ID. I guess here we don't have to subtract 1. Unless... I guess, hold on. We need to go +1 because they don't start with 0. Oh. So the first in the first tile set, first GID will be 1. So if we pass 1 here, that would be 0, which is incorrect because they always start with 1. So we have to add 1, that's fine. There. Whoa. Still lagging a little bit. I'm not sure if it's not rendering the map or if it's just off screen. Tire bounce 64. Let's have a look at the... So our tiles are 32 by 32, despite what the title says. So they're this large. Yeah, that's correct. That's 64 here. That's the index. And 0 and width and height is 32. That is correct. That is actually correct. It's still laggy for some reason. And it doesn't actually render the map. Let me check, maybe. Let's go into the entity manager. I want to try something here. Let's comment this out. And just always use the same sprite batch. Just for testing purposes. Not sure if maybe the lag is because it uses different sprite batches. No. Same result. That's weird, because like I said, it's not that I haven't used tile maps in previous projects. It's just that in the previous project what I did is I created the tile map programmatically instead of importing it from tiles, but that doesn't make a difference. So I don't know why it's so performance heavy apparently. I mean, okay, it has to iterate over all of the tiles in each frame. But that shouldn't be a big deal. It's not that many tiles. I just want to finish this here and have the map shown. Come on. What's the problem here? Let's offset the map for testing purposes. Let's go minus 100, minus 100 maybe. It doesn't seem like it's drawn. That's weird. $11,000. $11,000 doesn't make sense. Does it? I mean, it should basically be this position in pixels. So 32 by, I don't know, something, but not 11,000. So what's the deal with that? Let's check again here. Tile width is, oh, will you tell me? Tile set ref, tile set, tile width is 32, that's fine. Wait. For some reason, oh my. Yeah, okay. For some reason it only increments X, but not Y. Something wrong here, but what's wrong here? Tiles could be, it's fairly simple. 900. Height 1? That's not correct. So no wonder it's not working. The height is not 1. Yeah, for some reason they're all in the same... Oh my. The tiles are all added at the first row for some reason, so we made a mistake somewhere along the line. Maybe our parse method is not correct? Oh, I know it. I know what's wrong. It probably doesn't use the... It probably just uses this to indicate a new line. Without the \r. And that's why it thinks there's only one line. Which explains a lot. So, we'll have to rebuild this. And also rebuild pipeline. Then go into content. Area out of bounds. Let's debug this. So that was the problem all along. We have 30 lines, that's correct. Okay, so now it's working. I guess with the, yeah, obviously with the \r/n it wasn't working. Otherwise we wouldn't have 30 lines now. So that's fine. Now let's get the IDs. It's also 30 IDs, that's fine. Yeah, that's fine. Yep. So we have 30 lists of tiles, which is exactly right. Tiles. That's also correct. Here. No. So for each tile row. Oh, that's fine. Ah, we forgot to reset the X here. That's it. Now re-import. Yep, now it's working. Save. Now the position is 32. Yeah, that looks correct. It's still laggy. Why is it so laggy? Doesn't make sense. It's not that many tiles, so that can't be the reason. Okay, something's wrong here. So the tiles are there, but there's also this weird thing going on, and I think that has to do with why it's lagging. What is this? Is it from the other tile set? From this object tile set? Yeah, those are supposed to be the tree and whatnot, the house and stuff like that. So there's something going on there. So for each tile there. Oh, I know why, I think I know why. If we go into the tile map class, get tile set by here. If we select the first one, where the GUID is less than or equal to, that's wrong, because then we will always get the first tile set. We'll have to do last or default. Yeah. So now it's properly rendering, which is fine, but it's still laggy, and I don't know why. I mean, obviously it takes a little bit of performance to iterate over all the tiles, each frame. I get that, but it shouldn't be that bad. It's not that I'm doing this for the first time, so I don't know what's impacting the performance so much. It's weird. I mean, it's great to see that it's now rendering, but why is it so laggy? This can't be happening. I mean, we will have to iterate over all tiles. There's no way. There's no other way. I mean, technically we could generate a mesh from the tile set, or for the tile map, and just render the mesh. That would be an option, but it shouldn't be that big of a deal. It's not that many tiles. The thing is, if I don't do this, it's no longer laggy, I think. Yeah, so it's definitely caused by the rendering, but why is it that bad? Shouldn't be this bad. Maybe we're using draw mode instant instead of deferred, which would mean that it sends the draw call directly to the graphics card instead of basically aggregating them. So let's see. Entity manager. When we create the renderers, the sprite patches. Oh no, actually, we just need to... Get the sprite patch, begin, then... It's fine, here let's say... sprite deferred. All sprites are drawing when end invokes, and that's the signal. I think this is the default, so this can't be it. Still laggy. We even cache the tiles. We don't even create that many tiles. We create we create individual tiles for each different ID. So can't be that bad. So this is weird. Is it maybe because of the physics? Shouldn't be. It's weird. I mean, the map is rendering perfectly, that's just fine. But this lag is unacceptable. Okay, for some reason, we have 6 tilemap rail renderers in here. Which is weird, because there should only be 2. So yeah, that's a problem. So yeah, I guess everything is actually correct. For some reason we just add too many renderers here. Let's go into the scene here, into the process tilemap. Do we call it twice or something? No. Let's go here. Let's see how many iterations this loop actually does. So we have the first layer, ID 1 looks good. You add a new renderer here, that's fine. Next one, next layer is ID 3, which is correct because the second one is a collision layer, which we can ignore. Add, there we go, and that's it. Then why are there... Oh, because we never clear the entity. Oh my god. Oh my god, okay. There's a general flaw with our entity manager. We never clear the entities to remove. Entities to add and entities to remove. That causes the entity manager to repeatedly add these entities to the game. Every single frame. So that means over time we have thousands of entity of tilemap renderers in our game, and that's what causes the lag. So here we need to go entities. Come on, this entities to add, clear, and same thing with entities to remove. This should fix it. Oopsie. Yeah, now it's no longer lagging. Okay. I was almost losing my mind here, like, how could it be that a map with 30 by 30 tiles causes so much lag, but no, it doesn't. We were just rendering it basically hundreds and hundreds of thousands of times each frame because we repeatedly created new renderers, but now it's working fine. So that's great. So the rendering works. Next thing would be to actually create collision detection for the map. By simply parsing over the objects. And I think that's a thing we can do next time. I've been streaming for 6.5 hours, oh my. But yeah, it's working fine, that's good. Obviously there's no collision, so whoops. So I can remove this. Let's see if I can clean up the code a little bit. But I think it's pretty clean already. Yeah, that was a pretty severe bug here. And so basically every entity that we ever added to the entity manager was repeatedly added each frame. So yeah, not a good thing. But now it's fine. I kind of want to keep going, but also it's late. I don't know. I guess one thing we could still do, because it shouldn't take that long, is to be able to place objects here, like game entities, in tiled. I think it's faster than actually implementing the collision, because it's actually fairly simple. I'm going to add an interface here. Let's just do that and then we'll call it a day. placeable. Is that spelled correctly? I think so. Yeah. So let's create an interface, call it, I'm going to call it iTileMap_placeable. And it's going to inherit from iGameEntity. And it'll have a method, which here I put it in iGameEntity, but I decided let's use a different interface for that. Initialize. And it'll take the content manager and an instance of property map. Oh yeah, I have to implement that as well. Well, not sure if I want to do this tonight still. I mean, it's fairly simple. The property map is really just a dictionary. We could as well just use a dictionary. But it's supposed to have some convenience methods. So basically this property map would be to store the properties that we define here in the custom properties settings. So when we add an object here, we would give it custom properties that we want to pass to the initialize method here in this interface here, and then our game entities would implement this interface, and yeah, then we parse over the objects and get the properties here that we specified here in tiled, and then pass them over to this initialize method. That's the idea. I guess it can be a string. Because here you will always define, in tiled you will always define them as strings, I guess, here. Like, I don't know, some property, then here, some value. This will simply implement the iDictionary interface. We can quickly implementing it by saying implement interface through properties. There. We'll just use this field for the implementation. But I wanted to have some convenience properties like convenience methods like getInt, and then it will just simply parse the value like this. Let's say prop key we could also use the parse method of the integer structure. Let's keep it simple now. And I think, oh yeah, also get double and get float. That's all we need basically. technically we wouldn't even need get float. There. So this way we can pass an unspecified number of properties to this initialize method, and we'll take the properties from what we defined here. So I guess for that we would have to go here. I think we already, in our object group here, we already have these properties. Yeah, we do. But now we need to convert them to a property map. So let's read out in the tile map processor. Yeah, we need to, oh, hold on. In our tile map class, oh yeah, we don't have the object layer yet. So we have this tile map layer class, which is abstract, and we have a concrete implementation, which is tile map tile layer. But we also need the object layer. We don't have that yet. So, not sure if we want to do this today still. It's gonna take a little bit of time. Also need to define the object class. Hold on. Object data. So we have, for our purpose, we have 3 different object types: polygons, rectangles, and points. So to differentiate between those, I guess we can go here, tile map layer. First of all, let's move this into a different class. Let's say public enum tile map object type, and the first one would be rectangle with a G, point, and polygon. Now this needs to be a property here. Yeah, kind of opened a box here that I didn't actually want to open. I don't know. Now, all of the objects can have, I think they do share some properties. If we take a look at our example file here. So all of them have an ID and a name. And an X and a Y value, I guess. Well, this one doesn't have a name, but I think that's only because I didn't specify a name. In the editor. I guess that's the only properties that they share. And for now we only need the point, because I only want to implement the spawning of objects. Oops. And I guess the point doesn't actually have any more properties than that. Fine. Oh no. So we have to also, when we process the time map data, we have to also process the objects. Say tile map object layer. Hi Pistolfy. We've been streaming for a while. I actually wanted to call it a day a couple of minutes ago, and then I kind of got into also implementing objects here for the time maps. I don't know. Let's see. Yeah, actually, like I said, I wanted to actually call it a day and be done with the stream, but I kind of want to see the time maps are rendering fine, and now I wanted to also implement spawning objects from that we specified in the tiled editor. But maybe that's a topic for next time, I don't know. So yeah, I think that's what we'll do. So I think I'm gonna call it a day. Thanks for tuning back in, Pizzlify. But I think I'm going to actually call it a day. A to-do list would actually be a good idea, I think. Maybe I'll just prepare something for the next time. That we can have like a to-do list where we can scratch off the items one by one. But yeah, I guess you're right. Okay, so again, thank you. Thanks to everyone who stopped by, who tuned in, and hopefully enjoyed the stream. Don't know when I will be streaming next time. Not tomorrow, definitely not, because tomorrow I'll have to work on the new T-Rex video. I have to edit it and render it in the T-Rex Runner series. If I get to it, hopefully. But yeah, I don't know. I don't know when I will be streaming next time. Sometime this week, but I don't know the exact day. So, again, thank you everyone, and see you next time. Can you play lo-fi next time? Yes, sure, can do. But I have to be careful with the music because, you know, copyright claims, and it has to be stream safe, so yeah. So thank you all very much, have a blessed day, and see you next time. Bye.